right? Only 5 to 6 number of variables can be supported by the K-map. Then if suppose if I have more than 6 variables, okay, if I have more than 6 variables, then another method I can use is Quine-McCluskey method. Okay, so by using this is another method uh, where I can reduce the Boolean expression. Okay, and another important point of this Quine-McCluskey is this is based upon the prime implicants to find out, to determine a prime implicants. Okay, hence we know that the prime implicants are a product terms or sum terms. It may be a max term or min term, right? But which cannot be further reduced by combining with other product or sum terms of the Boolean function. That type of uh, terms can be reduced by this Quine-McCluskey. Okay, so that is what this method is useful to get the prime implicants. Okay, by using what this methodology, xy plus xy bar, xy plus xy bar equal to x into y plus y bar. X is common here, so taking it outside, y plus y bar, where y plus y bar is going to be 1, and then x into 1 is x, or that is what 1. Okay, so whereas how this Quine-McCluskey method is going to work. Okay, we will first, it is being described in the procedural steps. There are 6 steps. Okay, there are 6 steps. So let us see how these are going to work. Okay, step 1. So here in the first step, what usually we will get is we will get a one function like in the example. So this is the example, this is the problem that has been given, which has to be solved by using a Quine-McCluskey tabular method. Quine-McCluskey tabular method. Okay, so what can be done? What is the first one is arrange the given minterms in an ascending order. There may be a minterms or there may be a max terms. First thing what we have to do is arrange them in an ascending order. How can you say an ascending order? How can I say an ascending order? Like based upon the number of ones present in that midterm, in that what the input variables. Okay, how it can be done? Let us see. This is the first step. Okay, let us simplify the following Boolean function, whereas summation of m2, m6, m8, m9, 10, 11, 14, 15. Okay, so this is a 4 variable function. This one already the minterms are given up here. The minterms are given up here. Okay, now this is the first step that I'm going to do here. What I'm going to do here is the ascending order of these minterms based upon the number of ones present in their binary equivalent. See, when I go for a 2, the minterm 2, m2 will be having 0, 0, 1, 0, right? Where this minterm, the second minterm, is having the input variables of 0, 0, 1, 0. This is the input. Now, in this input, I have only one bit that is equal to the value of that one bit is 1. That is y bit. The y bit is 1 here in this midterm 2. Just a minute, I'll come back to you. Okay, fine. So, first step is ascending order. Whatever the given midterms are there, out of these midterms, make the arrangement in the ascending order. Based upon what? Not based upon the number 2, 8, 6. Here 8 is greater than 6, no? So, not based upon the numbers, but based upon the binary numbers, based upon the bits which are equal to 1. Okay, so in min terms, first group what I will do, I will collect only one bit which is equal to the value of that equal to 1. So I'll take 2. When I take min term 2 here, from this 2 is having 0, 0, 1, 0. Okay, so here I have only one bit is equal to 1. Rest all bits are equal to 0. So 1 is there. Then I will take next 6. If I go for 6, I will be having two ones here. 0, 1, 1, 0. Right? Two ones are there. But I don't want this. Where I will go? I'll go for 8. Where the value of 8 is 1, 0, 0, 0. But how many number of ones are there? Only one is there. So this and the value 2, the midterm 2 and midterm 8. I am going to make one group here. Okay, in this group only one bit is equal to 1. Then I will check, I will go for 6, 9, 10. Whereas 6, 9, 10, 11. 6 is 0, 0, 1, 0. Sorry, 0, 1, 1, 0. 9 is 1, 0, 0, 1. 10 is 1, 0, 1, 0. 11 is okay, 1, 0, 1, 1. I'll not go for 11. I'll just go for 6, 9, 10. I will make one group which is having the midterms 6, 9, 10. Why I'm going to make a group of these? Because these values are having equal number of ones and zeros. Okay, see like this. 1, 1 is there, 2 ones, here also 2 ones, and in the 10 also 2 ones are there. So this is the second group. I am combining 6, 9, 10. This is the first step, ascending order, arranging the binary numbers into ascending order. Okay, then where I will go? Then I will check for the groups which are having 3 number of ones. So that is 11 and 14. 1, 1, 1. 3 number of ones are there. Here 1, 1, 1. Another 3 number of ones are there. So I am combining these two. I'm I'm giving it name as group 3. And one more group I will get where I am getting 4 ones. 15. Right? 15 is represented as 1, 1, 1, 1. So I'm making that separate group. So like this, I am arranging them in a ascending order. And then I am making a groups based upon the number of ones. Okay, so that is the first step. Then, so now the first step is very simple. Then here, compare the midterms present in successive groups. See, like here, adjacent groups. I have group 1. What is the successive group is? Group 1 and group 2. What is another successive group for group 2? group 2 and group 3. And which is another successive groups? Group 3 and group 4. Like this. 1, 2, 2, 3 and 3, 4. I am going to compare the value of these groups in such a way that it should be in an incremental. Right? Now here, second, compare the minterms present in the successive groups. If there is a change in only one bit position, okay, if there is a change in only one bit position, then take the pair of those two minterms. Take the pair of those two minterms. Place this symbol wherever change is there. Place the hyphen minus symbol. Okay, in the deferred bit position, and keep the remaining bits as it is. See, just I'll repeat this. Compare the minterms present in the successive groups. Okay, that I will compare. And then if there is a change in only one bit position, in one minterm there may be a 0, in another minterm there may be a 1. Okay, so this, then take the pair of these two. If there is only change in one bit, then take those two minterms and place the minus symbol wherever it is differing. See how I'm going to do it. Now I will show that here. Now how I can do that? Here, say for an example, first I will take one minterm from this group 2, and from this group, second group, I will take 6. 0, 0, 1, 0, 0, 1, 1, 0. Now, is there any change between these values? And that change should be only one change. Do I get only one change between 0, 0, 1, 0, 0, 1, 1, 0? Yes. Here it is 0. Here also it is 0. Here it is 0. Here it is 1. Now one change. Here it is 1. Here it is 1. No change. Here it is 0. Here it is 0. So again no change. So out of this minter and this minter 2 and 6, only one bit is going to be changed. Only one bit is going to be changed. That is why what I will do in the next tabular, I will put one more tabular now where I am making a groups of these minterms. I will select 2 and 6. I will make a group of this. Now wherever the change is there, these are differing, you know. This is 0 and this is 1. At that position, I will put minus. How I'm going to write it as? See, this is the second table. So which are the minterms I'm going to combine? 2 and 6. Right? Where 0 is there, 1 and 0. Wherever 1 and 0 was there, the different was there. So there I am putting minus mark. And then 1, 0. This is what I have got. Okay? 1, 0 will get cancelled. No, that is why we are putting it minus. So I have got one group here, 2 and 6. Then here I have written 2 and 10. And the first bit is minus. Rest bits are 0, 1, 0. Now see how it is going to work. See, now I will take the same minterm comparing with all the minterms of group 2. First, I have compared with the 6. Now, I am going to compare this 2 with the 9. Okay, I will not go directly for the 10. I will go for 9. Now, check. Only one position should be different. Okay. Now, 0. This is 1. Okay, one change has been done. This is 0. This is 0. Okay, good. Already I have got one change. This is 1, this is 0. See, I have got two different values here. This is 1 and this is 0. This is 0 and this is 1. But this is 0, this 0 is same, and this 0, this 0. Okay, one more change I have got here. Three changes I have got when I compare group number 1, second midterm, group number 2, midterm 9. When I compare these two, I have got three different values to each other. So I will not make a group of 2 and 9. I will not make a group. Okay. Then let us check once again. Now I will not consider 2 and 9. Let us go for 2 and 10. Here it is 0. Here it is 1. Okay, one change. Here it is 0. Here it is 0. No change. Here it is 1. Here it is 1. No change. Here it is 0. Here it is 0. Okay. So out of this first, I have got only one change. Now what I will do, I will make a group of 2 and 10. I'll make a group. So after making a group, what I will get? See, only one group I will get from this. By comparing group 1 and group 2, I will get only one group. Next, by combining 2 and 10, 2 and 6, like this. See, here, 2 and 6 that I have done, 2 and 10, where the first bit is going to be minus because it is going to be deferred and rest are same as it is. Then it has been done, right? Group 1, group 2. Now in the group 1, one more term I have 8. Now I will compare the bit, that minterm 8 with 6, 9, 10. Okay, let us see. What is 8? 1. What about 6? 0. Okay, now one change. Here it is 0, here it is 1. Now second change. So I will not consider 6. 8 and 6 I will not consider. Then I will go for 8 and 9. Okay, it is 1. This one is 1. Okay, no change. This is 0. This is 0. No change. This is 0. This is 0. No change. This is 0. This is 1. Okay, now one bit deferred. So I will consider 8 and 9. Okay, then let us check next one. Then here 8 and 10. I'll go for 8 and 10. I'll consider 9. Then 8 and 10. Here it is 1. Here it is 1. Here it is 0. Here it is 0. Here it is 8. In 8 it is 0. Here it is 1. Now I have got one change here. And then here in the 8 it is 0. And in the 10 again it is 0. So in this 8 and 10 I have got only one difference. So I will consider 8 and 10. Okay, let us see how I'm going to write these combined terms. Okay, in the 9 it is the last bit, in the 10 it is the third bit. See, 2 and 6, 2 and 10, that I have already done. Then 8 and 6 was there, I have not considered. I will not consider 8 and 6 because 3 bits are going to be deferred. Now here 8 and 9, the last bit is being put up minus. 8 and 10, the third bit is put up minus, as only that bit is going to be deferred. Now this I am going to make it as one group. Now 2 minterms are there. I'm going to compare group 1, group 2, and I have created one group here in the second table. Okay, this is the second step. Now we are still in the second step only. Now what successive groups? Group 2 and group 3. Compare 6 with 11 and 14, 9 with 11 and 14, 10 with 11 and 14. Okay, so I'll come here. 6, I'll take 6 and 11. Okay, now 0, 1, so one difference, 1, 0, so two difference. Further I will not go because there are two differences are there. I will not consider 6 and 11. Then 6 and 14. Now here it is 0, 1, okay, one change. Here it is 1, 1, no change. Here it is 1, 1, no change. Here it is 0, 0, no change. So I will consider 6 and 14. I'll consider 6 and 14. See, I'm writing it as here 6 and 14, where only one bit is going to be different. That I'm putting it as minus. Then the same way, if I go for 9, 11, 9, 14. So 9, 11, one group I will get. Okay, only 9 and 11 will be joined. 9 and 14 cannot be joined. Why? Because this is 1, this is 1, this is 0, this is 1, one difference, this is 0, this is 1, two difference. So 9 and 14 I cannot make a group. Then 10 to 11, 10 to 14. So out of this I will get both. Whereas in the both, see, for example, 10 and 11. This is 1, 1, 0, 0, 1, 1, 0, 1. Okay, one difference is there. So I'll make a group of 10 and 11. Now I'll go for 10 and 14. This is 1, 1, 0, 1. So one difference is there. 1, 1, 0, 0. So only one difference is there. So that is why I will go for 10 and 10, 11 and 10, 14. Okay. So the fourth bit and second bit are going to be minus here. See, fourth bit and second bit are minus. Okay. Then group 3. So how I'm going to make a group 3? Now I'll compare from the first table group 3 and group 4. Right? I will compare 11, 15 and 14, 15. So out of this what I will get? Here 1011, 1111. So one difference is there. 11, 15, one group. Here it is 1110, here it is 1111. So here also only one difference. So 11, 15, 14, 15. Both will I will get, I'll make a group. Okay, group 3. This is the second point. This is the second procedure. Okay. Now what I will do, I will repeat. Let us see the procedure. Understood the second step? Hopefully, I hope you have understood. Then, what is the third step? Repeat the step 2 with newly formed terms till we get prime implicants. We know that prime implicants cannot be reduced further. Okay. Let us see how it will work here. Now this table we have understood. Second step, repeat the second step now. Now here 2 and 6 is there. This is group 1, this is group 2. Now compare the group 1 with the group 2. 2, 6, 6, 14. Only one bit should be only one bit should be deferred. Okay, see, when I compare that 2, 6, 10, 4, 2, 6, 2, 6, it is 10, 14. Okay, 10, 14, this one. How it is going to be done? See, like this. This is 0, this is 1 bit differ. This is minus, no difference. This is 1, this is 1, no difference. This is 0, this is 0, no difference. So what is the difference? Only 1 bit. 2, 6 and 2, 6 and 10, 14, only one difference. If I take 2, 6 and 6, 14, here 0, here minus, change, here minus, here 1. Already it has been changed, so I will not go for 2, 6, 6, 14. I'll go for 2, 6, 9, 11. If I go for 2, 6, 9, 11, this is 0, this is 1, one difference. This is minus, this is 0, another difference. This is 1, this is minus, another difference. So I will not go for 9, 11. Let us check 10, 11, 2, 6 with 10, 11. Here it is 0, here it is 1, difference, one difference. Here it is minus, here it is 0, another difference. Here it is 1, 1, here it is 0, minus. So another difference. I will not go for this. So where I will go for 2 and 2, 6 and 10, 14. Okay. So like this, I will create one more table where out of these three groups, group 1 and group 2 are combined and it will be made one group. Group 2 and group 3 are made combined and it will be creating another group. So only two groups I will get here. So what are the minterms I am going to join here? 2, 6, 10, 14, 2, 6, 2, 10, 6, 14, here 2, 10 and 6, 14. Minus minus is there, 0, 1, one difference, 1, 0, 0, 0, same to same. So 2, 6, 2, 10, 6, 14. Then wherever the difference is there I am putting minus. So here I will get two minuses. Okay, 8, 9, 10, 11 and 8, 10, 9, 11. Then 10, 11, 14, 15, 10, 14, 11, 15. Okay, this I will get from group 2 and group 3. Group 2 and group 3. When I compare these two groups, I will get this one. Maybe the time may end soon. I hope you have understood till step 3. Hope you have understood till step 3. Now, step 4. What is step 4? The class may end soon. Okay. Don't worry. In the next class, we will continue if it is been ended. Right? Just first understand step 1, step 2, and step 3 first. Then we will see step 4. Hopefully in the next class we'll discuss this, but let us see what actually it is. Formulate the prime implicant table. It consists of set of rows and columns, prime implicants that can be placed in row wise and minterms can be placed in column wise. Okay, the place 1 in the cells corresponding to the minterms that are covered in each prime implicant. How that I'm going to do? So this is what I have got from the step 3. Then here, what I will do is I will merge which are same minterms, combination of minterms from adjacent groups. Okay, so that is what Since I have got this 2, 6, 10, 14, 2, 10, 6, 14. Both are same. So I will merge. I will combine these two. Not an issue. If I take this one or this one, both are same here. So from this group, I will take only one group, 2, 6, 10, 14. Right? The first one. And from these two, again they are same. 8, 9, 10, 11 or 8, 10, 9, 11. Both are same. 1, 0, minus, minus, 1, 0, minus, minus. So I will consider only one from this group. 8, 9, 10, 11, 2, 6, 10, 14. And out of this, again it is same here. From the group 2, it is same. 10, 11, 14, 15. 10, 14, 11, 15. Both are same. So I will consider only one group here. Then I will create one more table here. 2, 6, 10, 14. 8, 9, 10, 11 from the group 1 and from group 2, 10, 11, 14, 15. These are the numbers that I have got from the upper table. Okay. So further merging, I cannot merge now. This I cannot compare again now here. Okay, I cannot compare group 1 with group 2 as many things are going to be changed. So I cannot further reduce the prime implicants. It is not possible here. So since because they are differing in more than 1 bit, that is the point here. So here there are 3 rows that I have got. This one row, this is the second row, this is the third row.